Okay, so today we're going to have a look at test 4 of the McGraw-Hill 10 ACT practice tests, second edition. Question 1. 1 foot is equivalent to approximately 0.3048 meters. So 1 foot equals this. If a building is 65 feet long, what is the length of the building in meters? Okay. So this is going to be a proportions question, right? And we're solving here for x, the number of meters. If you notice, there's actually more than one right way to do this, but the way I've chosen to do it is to put feet on the left side and meters on the right side. So basically my conversion factor is written as an equation, and the bottom part is just the corresponding units for my unknown quantity. Okay. I could have also done it this way, where I write 1 feet is equivalent to 0.3048 meters, all right, and then that equals 65 feet over x meters. This would also work, right, where I have my conversion factor written sort of as a fraction here, right? So either way, you can cross multiply to find the answer. So you can, once you have this set up, you can actually erase the units, right? We don't need them anymore. And then we get 1 times x is x, and 65 times 3, let's grab the calculator for that. So 65 times 0.3048, that gives us 19.812. 19.812. All right. So that's going to be the answer for the first one, choice A. To keep up with rising costs, a carpenter needs to increase his $30 per hour rate by 18%. So we want to do an 18% increase. So we have to use what's called multipliers, right? So from 18%, you turn it into a decimal, 0.18, and you tack a 1 in front, making it 1.18. Then you multiply that by 30, and that'll give you your answer. So 1.18 times 30, and that gives 35.4 as the new rate. Contributions to the school dance fund are made by each of 4 student groups according to the table below. What is the average dollar amount of the contributions made by the 4 student groups? So we're looking for an average, so we use our average formula. Average equals sum over number, right? We know we have 4 groups, and the sum is just basically add these up, right? So you maybe can do it in your head, but let's just save some brain power. So 25 plus 40 plus 30 plus 15, and then divided by 4. Notice that I said it equals and then divided by 4. So if I just divided by 4 there, it would have only divided the 15 by 4. 27.5, choice D. And by the way, one way to fix that division error is to put parentheses around the numerator, okay, and then divide by 4. That would work. Bus X travels 40 miles per hour for 2 hours. So already I can actually calculate the distance. Miles per hour. Even if I don't know the formula, I can use the units to help me understand what's going on. So if I multiply these two together, I get 80, and the hours cancels out, which means that that's going to be miles, okay? So this is bus X, and then bus Y travels 60 miles per hour and does that for 1.5 hours, right? Which is also 3/2 as a fraction. It's kind of easier to use fractions here. So again, the hours cancels out. So I get, my number would be 60 times 3 over 2 in miles, right? Now here I would do 60 over 2 to get 30 on the top. And then 30 times 3 would be 90 miles, right? Now, I didn't even know what the question was asking for, but I just did this because it's the natural thing to do when you have those two values. What is the difference in miles between the number okay, so the difference in miles is 10, right? Which of the following is a value of r for which this is true? So all we have to do here is to t-chart. R minus 3, r plus 2 equals 0. We t-chart this and set this equal to 0, set this equal to 0. effectively we're just going to get the negatives of what we were presented with. So r is going to equal -2 and r is going to equal +3, right, when you add 3 to both sides. So -2 is the one that they were looking for. In parallelogram shown below, PS is 7 centimeters long. Okay. If the parallelogram's perimeter is 40, right, so we already automatically know this is 7, but we don't know this value. Let's call it x, and let's call this also x. So now perimeter, if we write an expression for that, it's adding all the sides together. 7 plus x plus 7 plus x. So that's 14 plus 2x. That's what our perimeter equals. And we know the perimeter is 40, so I could just plug a 40 in for here. 40 equals 14 plus 2x. And then we can subtract by 14, and we'll get 26 equals 2x, so x would equal 13, right? How many centimeters long is PQ? So always double check what the question's asking, and it is asking for that, so good. In the xy coordinate plane, if the x coordinate of each point on a line x coordinate, right, is equals 5 more than 5 plus half the y coordinate, 1/2 y, or what I like to do is make it y over 2, multiplying the tops and bottoms, okay, y over 2. Then they want to know what is the slope of the line. So m for slope is change in y over change in x. That is what they're asking about. And I always suggest during your setup phase to always write an expression for what they're asking for. In this case, it's delta y over delta x. Okay. Let's see. Right, so we have here an equation which says x equals. Normally when we deal with linear equations we have y equals. So let's try to get it into that standardized form. We start by subtracting 5 from both sides. We get x minus 5 equals y over 2. And then from here we need to get rid of this 2. The way to do that is to realize we can put parentheses around that and then multiply both sides by 2. You can also think of moving this diagonally across the equal sign, which is my preferred interpretation. And then we distribute this 2 into the parentheses. So we get y equals 2x minus 10. And at this point we can interpret this along with the paradigm of mx plus b, so that the 2 is really your slope. Okay. And so therefore we don't even have to do this part. We can figure out the slope on the fly just by looking at the equation there. A rectangular garden has a length x and a width of y. So let's draw a quick sketch, x and y. If the garden has its length reduced by 3 feet, okay, so the x is going to turn into x minus 3, and it has its width extended by 2 feet. So then instead of y, this is going to become y plus 2. Okay. The question asks, what is the area of the new garden? Okay. So the area we find by doing length times width. So it's going to be x minus 3 times y plus 2. Looks like answer choice J. If x equals 3yz squared, what is y in terms of x and z? So x equals 3yz squared, and they want y. What is y? So y equals question mark. Okay? Again, when we make our list, it's good to have a question mark item here, so we know what we're looking for. So anyway, we're trying to isolate y here, so we have to divide by everything that's attached to it via multiplication. So by 3 and by z squared, we do that to both sides. So we get y equals x over 3z squared. And that looks like choice A. In the figure below, what is the measurement of angle alpha? So we're looking for this angle here. The first thing that I notice is that I have 10 and 10, which makes this what kind of a triangle? Yep, you guessed it, isosceles, right? So I could put 55 degrees here, knowing that these angles are going to be equal. Now those two angles add up to 110, so if I take away from 180, that'll give me 70 degrees left over for alpha. Right? Which of the following is the product of these? Okay, so let's just rewrite. And x squared minus 4 So at this point we have to do a double distribution. So we start by distributing this to here. So that gives me 3 times x squared, and x squared makes x fourth, right? We add the exponents. Then I do the second piece. That gives me minus, because it's minus times plus. 4 times 3 is 12, x squared. Now I do inner, minus x squared. And the last would give me plus 4. So then if I combine these two together, I get minus 13x squared plus 4, along with 3x to the fourth. So that looks like answer choice C. In the standard xy coordinate plane, if a square has these 3 vertices, what is the set of coordinates for the final vertex? Okay. So let's try to get an idea of what's happening here. So it looks like this coordinate matches, right? So we pretty much have at negative 3 of a y value. We've got a point at 2 and at negative 2. Okay, and then the other point is at 2 in the y in the x and 1 in the y. So it looks like the other coordinate has to go here, right? So I would say it would be a negative 2 on the x coordinate, and it would be a positive 1 on the y coordinate. So negative 2, 1 is choice K. Alright, so here we just have to reduce this, and that's done by subtracting exponents, right? So x to the 8th over x to the 4th would be x to the 4th. Y to the 12th over y to the 3rd is y to the 9th. And z squared has nothing to cancel with, so that is choice B. By the way, if you're confused about why that is, if I had like x to the 3rd over x squared, x to the 3rd really means I have 3 copies of x timesing each other. X squared is 2 copies of x. So that's why these will cancel, right? And thus you subtract however many you have just to get sort of a remainder, and these would also cancel. So 3 minus 2 is 1, so that's why you have 1 left over. Okay, but anyway, that should be pretty clear. Which of the following is the value of n that satisfies this? So we have here log base n of 64 equals 2. So one quick way to do these is to use what I call the left, right, center method. And this is a method that will convert it back into an exponential. So you start with the leftmost item, which is the n here. That becomes your base. Then the rightmost item is 2. That becomes your exponent. And then that's going to equal the argument, which is the center piece, 64. So basically it's left, right, and then center. So you write the left, the right, and then equals the center. So n squared equals 64. We can square root both sides, and we know that n would equal 8. Choice H. Technically plus or minus 8, but didn't have negative 8. A survey is conducted among 700 high school students to see who their favorite college basketball teams are. If 250 students like the Hawks, okay, 200 students like the Vikings, 50 like the Bears, and the remaining like the Warriors, what is approximately percentage that answer the Warriors? Okay, so we want a percentage that answer the Warriors. Percentage is always part over whole times 100, right? That's what a percentage is. And so we need the part and we need the whole, right? So the whole we know is 700 because that's the total number of students. And the part is, well, we need to see how many we already accounted for in our tallies. So looks like 250 plus 50 is 300, then plus another 200 is 500. So there's only 200 that are left over in this remaining group, okay? So that's going to be the part that like the Warriors. And so from here, there's several ways you could do it, but easiest way is just use the calculator. All right, we could do 200 divided by 700, and then multiply the answer by 100. 28.57 rounds to 28.6. And of course, we could actually have canceled out these zeros. Would have made it a little bit easier. So this would have been just a 2. this just to 7. And then times 100 would add 2 extra zeros here. And then you could have done the long division, right? 7 into 20 goes twice, 14, get a 6, 60. And then this goes in to 56, which is 8 times. So you get the 28 with the remainder. If x squared equals 36 and y squared equals 81, which of the following cannot be the value of this? All right. So we know that if we take the square root of both sides here, we get x equals plus or minus 6, right? Plus or minus because, well, we don't know if it was a negative 6 that got squared to make 36. And similarly here, y would equal plus or minus 9. And of course, you should be familiar with all the perfect squares, but if you're not, you can use your calculator to determine that. So one possibility is we can get positive 6 with positive 9, which would make positive 15. We can also take negative 6 with negative 9, which would make negative 15, right? We can take positive 9 with minus 6, that makes 3. And then we could take positive 6 with minus 9, that would make negative 3. But there's no way we can get 0, right? By taking x plus y. System of equations shown below. Which of the following describes the graph of the system of equations in the standard xy coordinate plane? Okay. So the first thing I would do is I would see if these equations are the same by multiplying through by a minus sign here. So I'm going to sort of do minus 1 to this entire equation, switching every single sign. Now I could compare what I have originally with what I have here. And it looks like the 4y and the 3x match up perfectly. The only difference is the 12 versus the 8. So further, I can sort of solve for y, all right? But it's not quite necessary, but I'll do it anyway. So I divide both sides by 4, and I get y equals 3x over 4 plus 3. Versus here, I get y equals 3x over 4 plus 2. So you can see that the only difference is the y coordinate is different. Sorry, the y-intercept, and the slopes are the same. So if you have two lines with the same slope, you know that they're going to have this sort of parallel nature, okay? Because the rise over run is the same, they're never going to intersect. So we have two parallel lines, okay? So we know that we're in either A or B. And do they have positive slope or negative slope? Well, the slope is 3/4, that's positive. Choice B. Now, one interesting thing to note is that all the slope information is contained on the coefficients of x and y, all right? And then the sort of y-intercept information is there, all right? So you didn't have to actually solve it out, but that's okay. All right, so negative 6 over absolute value of negative 3, which is 3. And then this becomes, one way I like to do these is turn the 3 times 2, right? 6 is 3 times 2. And then this 3, so the 3's cancel. You get negative 2. What are the values of A that satisfy this equation? Well, this is just another t-chart. So negative y would be one of them. Negative z would be the other, right? So just as we did before, we could split this, subtract it, and so on, okay? In the circles shown below, C is the center and lies on this segment. Which of the following statements is not true? Okay. So one thing I can right away deduce is that anytime you have an x, you know the angles that are across from each other are equal. It's called vertical angles. So I know that this angle here would have to be 40, right? Let's see what else we can deduce. AB is parallel to EF. Can we deduce that? Yeah, I believe that we can. I believe that we can because we can know, well, okay. Let me see if we can start with something easier. Let's see. CF equals EF. CF equals EF. Well, this seems like it's not going to be true, necessarily. So that's right away standing out. BCE equals DCF. BCE, which is this angle here, equals DCF. DCF is this angle here. Alright. So we're going to need some more angles. So let's get started with that. So basically, whenever we have a diameter, right? Terrible drawing, but let me just make it a little bit better. Whenever we have a diameter, we know that there's going to be 180 degrees on either side of that diameter, right? So using that kind of a logic, we can assume that there's going to be 180 degrees in this sort of half of the circle, and 40 is already accounted for here. So the other 140 must be located here, okay? And then we could use a similar idea to do the other half. So it has to be 180 degrees in this half. There's already 80 accounted for. So that must mean this would be 100 left over to span this space here. Okay, so now that we know all the interior angles, we could do anything regarding those. For example, like this. So BCE spans from here to here. So that's 140, right? And then DCF. So we have 140. DCF also spans 140. So this one is true. AB equals BD. So AB is here, BD is here. That would be true if their angles are congruent, the central angles. So yes, we would say that is true, right? Angle BAC measures 70 degrees. Well, if you notice, these both are radii, which means that these angles have to be equal. So if we were to call them x, because we don't know them, then we could say that x plus 40 equals 180. The reason why I use the same symbol is because they're equal. Right? And then so 2x plus 40 is 180. Subtract 40, 2x is 140. Divide by 2, x is 70. Right? So, yeah, right? This is 70 degrees. AB is parallel to EF. So the way to do that is to show that this is also 70 and 70, because again, you have two radii. And then you can use alternate interior angles from here and here, because you have parallel lines cut by a transversal. They form alternate interior angles that are congruent. Right, so we've proven this as well. Right, you didn't quite have to prove all that. You can kind of just go with your hunch here, but it was a good exercise. What is the slope of the line given by this equation? So let's check it out. And the idea here is to solve for y, right? So let's see. I'll grab this 3y and I'll add it to the other side, which is currently empty. So then I would get 3y equals 21x plus 18. Then I divide by 3 on each piece individually. And I get y equals 7x plus 6. So if I want the slope, I just look where m is in mx plus b, right? And it looks like 7. Which of the following is the least common denominator for the expression below? Okay, so we have to look here at the denominators. So the first one is a squared bc, then you have b squared c, and then you have bc, right? So we're looking for a common denominator between these, and typically what we do for that is we try to fill in what's missing on each one, okay? So basically we take the highest of all the powers. So a squared bc is the first one, then we have b squared c, and then we have bc. So what we'll do is we'll fill in a 0 power for anything that's missing. Alright, and then we'll take the highest of all the powers vertically. So the highest in the first column here of the a's is a squared, the highest of the b's is b squared, and the highest of the c's is just c. So this, I claim, would be the greatest, or sorry, the least common denominator. A squared, b squared, c. So, why is that not a choice? A squared, b squared, oh, because this c is supposed to be squared. and so therefore this would be c squared, right? Choice J. What number can you add to the numerator and denominator of this to get that? So we're taking 5/8, we're adding something to the numerator, we're adding something to the denominator, and that's going to somehow equal 1/2, right? So there's our equation. We just have to solve it now. And when we're solving equations and we don't know what to do, I always use the following mantra, okay? So first step would be clear the denominator, if one exists. Then combine like terms, and then isolate. Sometimes you'll have an intermediate step where you have to do a distribution. Okay? So that would come in between steps 1 and 2. Alright, so now, by the way, whenever we have two terms with a long division sign, there's parentheses that are implied here. Right? That's why we can't simply cancel out those x's. Right? And anyway, so we cross multiply here. We get 2 times this quantity equals 8 plus x. Then we distribute the 2. 10 plus 2x equals 8 plus x. Subtract x from both sides. And then subtract 10. We get x equals -2. Okay. So yeah, choice C. If x plus y is 13 and 2y is 16, what's the value of x? So right away we could solve this one by dividing by 2 on both sides. We get y equals 8. Once we get that, we could then plug this 8 in for y in the other equation. So x plus 8 equals 13, minus 8 from both sides. X is equal to 5. Okay. If this inequality is true, then which of the following must be true? Okay. Well, let's see. Does m have to equal n? No, absolutely not, right? Because one way to do it is to have m equal 2 and n equal 1. Right? That satisfies this because 2 is greater than 1. Does m have to not equal n? I would say that that's true, right? If they were equal, then we would have an equal sign here. So already I'm choosing choice B as my answer, but if we want we can keep going. Does m have to be less than n? Well, I can make m -2 and I can make n -1. Sorry. Well, this shows that this is false, right? And then for the next one, yeah, for the next one I could use -2 for m and -1 for n, and then I still get a truth. So I've proven this wrong. And then does m have to be greater than 0? Again, when I started with -2, I proved that wrong. Right, given that y minus 5 equals, and instead of half x, I like to write x over 2 plus 1 is the equation of the line. At what point does the line cross the x-axis? Okay, so whenever we have a linear equation, we like it to be y equals. So let's add 5 to both sides, and we get y equals x over 2 plus 6. Okay, so at this point, we notice that what they're asking for is the x-intercept. Okay, so when we're looking for intercepts, what we have to do is set the other variable equal to 0. So in this case, since we're looking for x-intercept, we set y equals 0. Okay, so 0 equals x over 2 plus 6. We subtract 6 and find x over 2 equals -6. Multiply both sides by 2, and you find x equals -12. So that's going to be choice G. Now, if you didn't know how to do that, you could have, of course, put this whole thing in your calculator and then just looked at it and see where it crosses the x-axis. Right. The figure above shows the plan for the ground floor of a townhouse. The thickness of the walls should be ignored. The dimensions shown are in feet, and each region is rectangular. What is the area in square feet of the living room? All right. Well, there's a few ways to do this, but one way is to actually figure out what the dimensions are for this living room. Okay. So it seems as though this whole thing spans 18 feet, but this hallway is 4 feet. So that leaves 14 feet for this width of the living room. So let's do something similar for the vertical. So we have the whole thing spanning 20 feet, but then this kitchen area is 8 feet, which leaves 20 minus 8 is 12 feet for the vertical. Then if we multiply those together, we should be able to get the area, right? Area is length times width. So 8, 1 times 2 is 2, plus 14. So that's 168, choice D. What is the perimeter in feet of the ground floor of the townhouse? Okay. So, yeah, so we have to find the perimeter of this thing. So let's do a little erasing here. Well, yeah, I'm not sure if they just want the outer edge. Let me see here. Yeah, it's kind of hard to say, but let's assume, let's assume they just want to know the outer edge, the perimeter of this, right? So that would just be 20 on each side and then 18 on the top and bottom. So that would be 20, 40, 60, 80, subtract 2 and 2, subtract 4, 80 subtract 4, 76. So we'll go with that. 3 years ago, the population of a certain species of bird was calculated at 20 birds per acre. Notice the fractional unit here. Birds per acre. This year, a biologist recorded a total of 47 birds. 47 birds in an area equal to 3.25 acres. 3.25 acres. So again, here we have a fractional situation. By about what percentage has the population increased? So they want you to find the percent increase, okay? Where this is the original and this is the final. So a few ways to do this, but the first step is to just calculate this as a number, right? So we go to our calculator here and we put in 47 divided by 3.25. That gives us 1446. 14.46 birds per acre, right? So at this point, notice that this is a partial answer, okay? So that's very, very unlikely to be the correct answer. Yeah, so at this point we have to find the percent change between the number 20 and the number 14.46. So one way to do that is we could use our multipliers formula, which is original times multiplier equals final, right? And we know the original is 20, multiplier will use x, final is 14.46. Sorry, this is a percent decrease, by the way, not increase. So then we divide by 20, right? That'll give us x, which is our multiplier. So we do 14.46, which is already in there. So we just can divide, or do like answer, divided by 20. 0.723. 0.723. Now we have to interpret what this multiplier means. So multiplier corresponds to the percent on. So 72.3% on. And then we could further interpret this with a percent off if we take it away from 100. So 100 minus this would give us 27.7 or so, right? So it's 27.7% off, which is the percent decrease that we measure. A right triangle that has sides measured in the same unit of length is shown below. For any such triangle, this is equivalent to. So the tan of alpha, so here's alpha, sine of beta, here's beta, right? Well, let's see. So the tangent of alpha, we can use SOHCAHTOA, right? SOHCAHTOA. And we know that this is going to equal opposite over adjacent, right? So we have to use alpha's perspective here and find the opposite side. So notice how this touches two sides. The opposite side would be away from that. So that's z. And then the adjacent side is the one that's not the hypotenuse. So, whoops, sorry. So this is, of course, the hypotenuse, and then this would be the adjacent side, which is x. Now that's from the perspective of angle A, or alpha. So next, we have to look from the perspective of beta, and we have to find the sine of beta. Okay? So I'm going to erase these now, so they don't no longer apply when we're looking at beta. So from beta's perspective, this is the opposite side, this is the adjacent, and this is the hypotenuse. So for sine, we're doing opposite over hypotenuse. So from beta's perspective, that would be x over y. Right? And now our task is to multiply these results together. So z over x times x over y. And then we notice that these x's will cancel out. We just end up with z over y. Right? So is that a choice? Yeah. Good. For all x greater than 0, 1 over x plus 3 over 4. Alright, so this is one of my favorite little tricks that I like to use. Basically, when you're combining fractions that have different denominators, in particular if they're coprime, meaning that they're not multiples of one another, what I do is I use my cross multiply method. Okay, so we do 1 times 4 and get 4, then we put the plus symbol, and we do 3 times x and we get 3x. Then we have to divide by the product of the denominators, which is going to make 4x. And that is choice C. So it's a quick way of combining two fractions with different denominators. Cross multiply method. If cosine of A is 4/5 and sine of A is 3/5, then what is the tangent of A? So one way to do this is that the tangent is always equal to the sine over cosine. So if the sine is 3/5 and the cosine is 4/5, this is a good time to use our keep change flip method, right? So we keep this fraction the same, we change the division to a multiplication, and we flip the bottom fraction to make 5/4. At this point, these two 5's can cancel, right? Because really it's division here, multiplication here, and with PEMDAS, right? P-E-M-D-A-S, M and D are on the same position, meaning that you could do them in any order you want, so we're going to choose to do the division here first. So we end up with 3/4 as our result. It's choice F. In the xy coordinate plane, what is the y-intercept of this line? So 5x and 3y equals 8. We wanted to read y equals because that's the proper form to analyze the results. So we get 3y equals minus 5x plus 8. Then we divide by 3 in each and every spot. And we find y equals negative 5/3 x plus 8/3. This being the y-intercept. Alright, if a to the x over a to the 4th is equal to, a to the x over a to the y is equal to a to the 4th, which is the following must be true. So this is our rule 2 on our exponent rules, where we subtract the exponents. So we get a to the power x minus y equals a to the 4th. Now if you ever have a number to a certain power equals a number to that another power, those powers have to be equal. So we can in a way drop out these a's. X minus y equals 4, right? So that's choice J. In a certain music store, CDs were put on display and assigned prices for May. Each month after that, the price was 20% less, right? So there's 20% decrease. So that we should be thinking multipliers, right? So what's the multiplier for 20% off? Well, we know 20% off is 80% on, and we always care about the percent on, right? Because that's the part that we're actually paying. So turning this into a decimal, we get 0.8, right? Move the decimal twice to the left. That's our multiplier, okay? If the price of a CD was D dollars in May, what was the price in August? Okay, so we're starting with an original price of D dollars, and we have to apply the multiplier of 0.8 several times. So how many times? Well, how many months have passed? So we went from May to June to July to August, right? So that's 1 month, 2 months, 3 months, okay? So in those 3 months, we would need an exponent of 3 on this, right? So 0.8 to the third power, we can use our calculator here. 0.8 to the third, and we get 0.512 d. Okay, so that's going to be answer choice C. The absolute value of 5 minus 2x is greater than 5. Which of the following is a possible value of x? Right, so whenever we have an absolute value problem, we split it into two different problems. The first problem will have everything exactly the same except no bars, no absolute value bars. The second one, the absolute value side stays exactly the same, and then you have to switch two things. You have to switch the inequality sign to be the opposite, and then you have to switch the right-hand side to be the negative of what it is. Okay, so both of these things switch. Now, we solve this by subtracting 5 from both sides, and we get negative 2x is greater than 0. Then we divide by negative 2, and we find that x is greater than 0. Right? From here, we subtract 5 both sides. We get negative 2x is less than negative 10. Divide negative 2, and we find that x is less than 5. So, if we chuck this up on a number line, here's 0 and here's 5, right? We know x is less than 5, which means this side. We know it's greater than 0, which means this side, so we shade the middle. And these are sort of open circles here. So anything between 0 and 5 is acceptable. Actually, I made a mistake. Right? So when you divide by a negative, you have to flip the inequality sign. Right, so that's kind of a rookie mistake here. So when you divide by a negative, yeah, this inequality sign from greater than switches to less than, alright, 0. And then here, this less than switches to greater than. Okay, so, 0 and 5, open circles, and instead of, shading inwards as we did before, we actually want to shade less than 0, which is kind of the side here, and then greater than 5, which is this way here. Right? So anything outside is acceptable, and the only one outside is this. So just so you know, like anybody's capable of making mistakes, right? What value of t will satisfy this equation? 0.1 times t plus 3420 equals t, right? So let's see. We can distribute the 0.1 into here. So 0.1 t plus, and multiplying by 0.1 is kind of like dividing by 10, right? So when you divide by 10, you're just going to cancel out that 0. If you didn't know that, you could use your calculator there. Do 0.1 times that. Anyway, we're up to here. So we subtract by 0.1 t. 0.1 t. And by the way, this is 1 t, right? So 1 minus 0.1 is 0.9 t. Okay, equals 342. And here we're dividing by 0.9, right? So we can use our calculator at this point. So we can do 342 divided by 0.9, and we get 380. Choice E. What is the slope of any line parallel to the y-axis? So if we have something parallel to the y-axis, it might look like this. So at a certain x value, maybe this is x equals 6, in which case the slope is sort of infinity, right? Because you'd have to climb an infinite amount up to go any amount over. We call that undefined, right? Which of the following lines has the smallest slope? Right? So the slope is in front of the x. This is a slope of 1, 2, 1/2, 15. Whoops, actually these are not in standard form, so we have to divide by 5 here, and that will give us a 3. Divide by 7 here, it gives us 3/7. So 3/7 is the smallest number there. Amy can run 3.5 miles in x minutes. So again, here we get a fractional unit. At that pace, how many minutes would it take her to run this? Okay, so this is a proportion. And we can put the 10.5 miles here, and question mark minutes. Alright, so in this case we're solving for question mark, And our answer is supposed to be in terms of x. So just treat x as though it's a regular number, okay? So we're going to do a cross multiplication, and when we do that, I like to get rid of the units just to make it a little bit clear. So we get 3.5 question mark is equal to 10.5x, okay? And instead of question mark, you can use y if it's more comfortable for you. Divide by 3.5, divide by 3.5, right? And so you get this for a question mark. And now we just have to divide the numbers. So 10.5, divide that by 3.5, and we get 3. And that, of course, will go in the numerator where the bigger number is. So 3x. All right, a certain rectangle is 5 times as long as it is wide. So the length is 5 times the width. Suppose the length and width are both tripled. That means we take the length to 3L and we take the width to 3W. The perimeter of the second rectangle is how many times as large as the perimeter of the first rectangle? All right, so there's different ways to do this, right? But the first thing we want to do is we want to look at the perimeter formula for a rectangle. So it's really 2L plus 2W, right? If we have a perimeter, length, width, width, we sort of just add up all those, okay? So now, at this point, here's the first way we could do this. We could change L to 3L in the formula, okay? Do the same thing for W, change it to 3W. And we can call this P prime. That's our new value for P, right? And what we notice here is that we get 6L plus 6W, right? So we have to compare that to the original, which is 2L plus 2W. All right, so the idea here is it's like 3 times larger, right? So the answer would be 3 times larger than the original. And one way you could see that from the previous step is you could sort of factor out a 3 at this point. If you factored out a 3, you'd be left with 2L plus 2W, right? So this is 3 times the original, right? Now, in general, this subject is called proportionality, all right? And you can look at the type of proportionality between two variables by just looking at the general formula for that. So in particular here, when we're talking about perimeter with respect to length, let's say, there's a direct proportionality here, meaning that if I was to increase L, P would increase by the same factor, right? So in this case, if I was to triple L, P would triple, okay? Sorry. Well, not quite, right? Because there's two terms. The idea is if I was to triple both of these, then I could factor out the 3, and it would cause a tripling of the output variable. So it gets a little dicey here, which is why that first method that we use is preferred in this context. Okay. If r and s are constants, and x squared plus rx plus 12 is equivalent to this, what is the value of r? Okay. So they like to throw one of these questions on every test, it seems, where you kind of have to FOIL out one side so that it looks more like the other side. So here x times x is x squared, and then the outer will give you 5x, inner would give you 3x, and the last would give you 15. Okay. Then we just sort of set like terms equal or kind of combine them, right? So in this case, we have a 5x and a 3x. Those can combine to 8x. All right. And let's see. Sorry, this is not 15, is it? So that's not a 5. It's supposed to be an s. Whoops. So this is where my handwriting gets me in trouble. So x squared plus, instead of 5, this should be sx, right? So this is not an 8. This is a s plus 3. S plus 3 is the coefficient in front of our x. And then this is 3s, not 15. 3s, okay. So now we subtract by x squared on both sides, and that's just going to cancel. Okay. So now we can set our coefficients equal on both sides. So we know that r has to equal s plus 3. And we also know that 12 has to equal 3s, because those are the constant terms. So if I divide by 3 here, I can find s. S would equal 4. Then I could take this 4 and plug it in here to find r. So r would equal 7. Choice H. They're asking for r, right? For what value of b would the following system have an infinite number of solutions? Right, so if we're looking for an infinite number of solutions, the only way for that to happen is if both of these equations of a line were representing the same line, okay? And the only way to get that to happen is if they're identical to each other. You know, you can also multiply by a constant, for example. So I notice if I multiply this by 4, I'll get sort of the x's and y's to match. So let's start with that. So 12x plus 20y equals, and then 27 times 4, you get 28, and then 4, 8, 10, so 108. Okay, now I could compare these two equations that I have. The left sides are already equal. What I'm going to demand is I want the right sides to also be equal. Okay, so I divide by 3, and we get b equals, well, what does this equal? So 108 divided by 3, 36. Right. Which of the following calculations will yield an even integer for any integer a? So these even and odd problems are fun because all you have to do is choose one odd number and one even number, okay? And then sort of one of them is going to pass both tests. The rest of them are going to fail one or the other or both. So anyway, I like to start with 0 because that's a nice easy number to plug in. So we're looking for the output to be even. So when I plug in 0 here, this whole part disappears, right? I just get 3, which is odd. And I want even, so that's out. Same thing here. Here I'll get 1 when I plug in 0, right? And when I plug in 0, all the a's stuff will cancel. So the only ones that will survive the test are this and this, right? So that was easy. I'm already down to 2 possible choices. Now, between those two, I have to now try my odd number. So I have to plug in 1. So when I plug in 1 here for a, I get 1 squared is 1, times 5 is 5, plus 2 is 7. That's no good because I need an even, right? So the only one that works is j. And we could actually have seen that if we sort of factored out a 6. Well, let's not even bother. What is the solution set of this? Okay, so again, here we have an absolute value inequality. So just as before, we're going to want to split it into 2, where the first one, everything is the same except no bars. And the second one, the left side, the absolute value side, it stays the same, but we switch the inequality sign, and we also switch the right hand side. Add 3. We get 3a greater than or equal to 15. Divide by 3, a greater than or equal to 5. Alright, so that's our first piece. Anything that doesn't have that can go. Right, this can stay. Alright. Sorry, negative 5. Whoops. Okay. Greater than or equal to 5. Yeah, just the top 2. Okay. And then we solve the other side. Plus 3, negative 9, 3a. Divide by 3. And you get this. Less than or equal to negative 3. So that's choice B. What is the cosine of this, given that this equals this and that? Alright. So when you see this kind of question, you actually don't need to do anything but just pop this in the calculator, right? So, but the only thing we have to make sure is that we're in the right mode. So let's try cosine 5 times pi divided by 12. And we get this weird number, which is close to 1, right? This is actually incorrect though. So if we look at our mode, right, notice we're in degree mode. And this angle here is not given in degrees. It's given in what's called radians. Whenever you see the pi, that's usually an indication that you're in radian mode. Okay. So let's put it into radian mode and try again. So now the calculator expects that we're going to get an angle in radians, which it does. So I just pressed enter, and this is what it gives me. So I just recalculated that. So it gives me 0.258 approximately. 0.2588. Now that's not an answer choice, unfortunately. But if you notice, right, these are sort of obvious decimals, but these ones might be more complicated, like what we've seen. So the best way to finish this problem is then to plug these in, remembering that we're going to need parentheses on the numerators for each one. Okay. So firstly, we have square root of 6 minus, so I have to close the parentheses, minus square root of 2. Alright, and then close the parentheses for the numerator, divided by 4. And luckily that gives us exactly the value we were looking for, 0.258. So that's our answer. Now if you're curious as to how to do this the quote-unquote correct way, I'll show that now. If not, you could just skip ahead to the next one. So basically we want to use this formula. Okay, it's the angle addition formula, and sort of alpha would be represented with this angle, right? So this is alpha. Just going to erase this. Alpha. And this here is beta, right? So when we want, for example, the cosine of alpha, we'll have to do cosine of pi over 4. So using the chart here, here's pi over 4, here's cosine. So it's going to be rad 2 over 2. So we take that, we times that by cosine of beta, which is cosine of the other angle, pi over 6. And we get that here, cosine of pi over 6, rad 3 over 2. And then we subtract sine of alpha, so sine of our first angle alpha here, which is going to be this, rad 2 over 2. And we times that by the sine of beta, which is the sine of this angle, 1/2. Okay. So now I multiply the tops, we get rad 6 over 4, minus rad 2 over 4. Common denominator is 4, so we just can write it once. And that's the answer choice we circled. Now if you're wondering why I'm not taking the sine of 1/2, it's because they already did a sine of pi over 6 for us and got the output to be 1/2. Alright. If y is not equal to z, what are the real values of x that make the following equation true? So the first thing you notice is, if ever you see anything that could be factored, then you should definitely try to factor it. So here I could factor out an x. Alright, and then here I could factor out a 3. And lo and behold, I find something interesting, which is that the parentheses part matches. And so I can cancel it out. And by the way, that's why they write y is not equal to z. If ever you see something like this, usually it's because of this little problem here where you're not allowed to divide by 0. So if that was 0, you'd be in trouble, right? So you could pretty much disregard that whenever you see it. It's just kind of they're covering their tracks, making sure that, you know, not to be called out or anything. So anyway, this cancels. So we get x over 3 is less than 0. We want to solve for x, so we multiply by 3, both sides. The 3's cancel here, and 0 times 3 is still 0. So we get s less than 0, which means that we're dealing with negative numbers. The perimeter of a square is 36. And the fact that it's a square, we have the formula for that. We just take 4 times the side length. And so then we can set the right sides equal here, because perimeter, we can sort of substitute. 36 equals 4s. We could divide by 4 and find the side length to be 9. So right away we find the side length. We're probably going to need it. How many units long is the diagonal? Okay, so for a square of side length 9, the diagonal we could find with Pythagorean Theorem, right? So we do 9 squared plus 9 squared square root, 81 plus 81 square root, so etc. But there's a shortcut. So the shortcut is, whenever we have this situation, we have really a 45, 45, 90 triangle, and so we can sort of look at just the triangle here, and the ratio of sides for a 45, 45, 90 triangle is going to be x, x, x rad 2, right? So whatever the side length is, the diagonal here is going to be that times radical 2. So we just go with choice G. What is the equation of the circle in standard coordinate plane that has a radius of 4 and the same center as this circle? Okay. So we're going to have to first get the center from this, and then a radius of 4 we know is going to appear as a 16 in our equation, because this calls for r squared in that position. Right, so let's try to get the center from this. To do so, we're going to have to use a method called completing the square. Right? So for completing the square, we want to group the x and the y terms together and put any constants on the other side. So we're going to subtract 4 to the right-hand side. And so now what you notice here is there seems to be a number missing here where you'd have a nice trinomial. Okay. So to determine what that number would be, we have to find what is called, which is the key number. And to do that, we take half of this value, so divided by 2. Then once you get that, you square that, and then you get 9. So you add that 9 to both sides, okay, that key number. So again, the key number method is you take the middle term, which is, you know, a, b, c, this is b, we divide it by 2 and square, right? Once we've done that, we add it to both sides, and now this part becomes factorable via trinomial factoring. So y, we have same negative, so minus minus, and then factors of 9 would be 3 and 3, right? That combined up to minus 6. Now 9 minus 4 is 5, right? So this can be rewritten as a square, right? Seeing as it's the same thing timesing by itself. All right. Now we're in standard form for the equation of a circle. So now to interpret this, since this doesn't have a shift, the center would be at 0 for the x, and this has a shift of minus 3 inside parentheses. So that actually turns into a plus 3, okay, for the y value, the shift of the center. So the center here is 0, 3. So we're looking for the same center in our situation here, so we should see x squared because we have no shifting on the x, but then we want the minus 3 for the y. Okay. A rectangular kitchen is 8 feet longer than it is wide, so the length is 8 more than the width. Notice what I did there? I changed it a little bit, the sentence, to make it more, right? The length is 8 more than the width. So I changed it a little bit just to make it more Math English Dictionary friendly, okay? And that's a good tactic to use when you're having a little bit of trouble turning a sentence into an equation. So anyway, its area is 240 feet. Now, I could write that this way. How long in feet is it? So length is question mark. So what you will find is that our setup is kind of incomplete here. We've got 3 unknowns, length, width, and area. And we only have 2 equations, right? So we don't have enough equations. We need one more. So it's going to be the formula for area. For a rectangle, it's length times width. So that gives us our third and final equation. Now we could do our analysis, right? Of course, the number of equations has to meet the number of unknowns. So here we have a 3 by 3 system. So that's solvable. How? Well, we use the idea of substitution, right? So the first substitution will come here. When I take 240 and plug it in for A, right? So I get 240 equals LW. And then I have L equals 8 plus W. So I can plug this in for L here. So 240 equals 8 plus W. And whenever we plug in, we use parentheses times W. And then we distribute this W. All right, so we get 8W plus W squared. Okay. Now we have a quadratic here, which means we want everything onto the same side. So we could subtract the 240 over, right? So minus 240 equals 0. And now we have to factor this. So we can use this, right? And hopefully we can come up with numbers that multiply to 240 and have a difference of 8. So let's look at some factors of 240. So the first one that comes to mind is 24 times 10, right? But they have a difference of 14. So I need numbers that are kind of closer together. So a neat way to do that actually is to look at, break these down even further. So this is 6 times 4 and this is 5 times 2. And then you could sort of recombine different factors here, right? So for example, I might take the 4 times 2 to make 8, and then the 5 times 6 to make 30. So 30 times 8 will also equal 240. So yeah, via this process we can perhaps come up with a good way to get 8 as a difference. And we might have to, of course, break down further from here. Let's see. So I found it, right? We could do 12 times 20. So 12 times 20, that will multiply up to this and it'll have a difference of 8. So 12 and 20 will be our answers. We always put the greater number first, okay? And then we always put this symbol, drops down into this position. Alright, and this minus here tells me that the signs are different, okay? So anyway, we get this, and we solve it out using t-chart. We get negative 20 and positive 12. We reject a negative solution, and we take 12 as our width. So if the width is 12, we need the length still, so we plug in 12 here. 12 plus 8 is 20 for the length. So notice, do not choose 12, which is a partial answer. Okay. What is the slope of a line that is parallel to this? Okay. So we just need a y equals form. So we can move the 4y to this side, and we can move the 8, making it negative on this side. Then we divide each and every item by 4, and that'll give us y equals, which is our standard form for that, and we get the slope of 5/4. Any line that's parallel will have the same slope. Alright, 3 to the 8x equals 81 to the 3x minus 2. So this is what I call a base problem. Notice that 3 is sort of, 81 is made up of purely 3's. Okay, you could do that. You can learn that by sort of looking at what it's made of, which is 2 9's, and then the 9's are each made of 2 3's. So this is really equal to 3 to the 4th. So that's what we're going to do. We're going to replace it by 3 to the 4th power. And then that, of course, gets raised to that power. So when you have a power raised to a power, you multiply the exponents. So we'll end up with 12x. Distributing here, we get 12x minus 8. And then as we've seen before, at this position we have to actually set the exponents equal. Alright. And then we subtract 8x just to make it positive. We get 4x minus 8 is 0. Then we add 8. We get 8 equals 4x. Divide by 4. We get 2 equals x. Right, choice H. Picture shown below has a uniform frame width of 5/8 inches. What is the approximate area of the viewable portion? Okay, so if the frame is 5/8, right, that's kind of here, and it's also here. So my vertical measurement, I have to take away 5/8 twice. So let's look at what twice 5/8 would equal. It equals 10/8, right? And that can be reduced to 5/4. So I have to take away 5/4 from my vertical measurement. So you take away 1 and then a quarter. So this comes down to 16.75. And you could use the same logic to also deduce two, basically the same exact number from here. Right, 2 copies of 5/8. So anyway, we end up with 28.75 here. Now we just have to multiply those together to get our new area. 28.75 times 16.75, and we get 481 and change. A horse eats 12 bales of hay in 5 days. So again, fractional units. At this rate, how many bales of hay does the horse eat in 5 plus x days? So here we have a proportion question, right? Notice the use of a question mark here because x has already been used. And notice, of course, the answers will have x in it. So we treat x as a number, you know, solving for question mark. So what we do is we could drop the units at this point, and we cross multiply. In this case, we don't actually fully cross multiply. We only move the 5 plus x diagonally to go here. Okay. And so then we just want to solve this out. So we could do that by distributing the 12. We get 60 plus 12x all over 5 equals question mark. And then we notice that these have actually two separate terms, whereas this here has a common denominator. So to make it look more like the choices, we could divide by 5 separately on both pieces. And then we get 60 over 5 is 12 plus 12x over 5. Is that a choice? Yeah. When graphed in the standard xy coordinate plane, the lines x equals -5 and y equals this intersect at what point? So x equals -5, we could plug that in for here. So -5 minus 5, so that's -10. Right? And we know, of course, the x value is -5, so -5, -10 is our answer. Which of the following expresses the number of miles a runner can run in a 4-lap race where the course is a circle of radius m miles? Okay, so let's see. So we have a track. Let's see. The track has a radius of m. 4-lap race. Okay. So what we want to do is find the circumference of this circle, right? Because that's the sort of distance around the circle. So we wanted to know the distance around, use circumference. Circumference formula is 2 pi r. So, and of course, let's see. We could substitute m in for the radius. So 2 pi m is the measurement for the circumference of this circle. And if we're going 4 laps around, then we have to do the circumference 4 times. So we do 4 times that circumference, and that will give us 8 pi m, which is choice J. For some real number n, the graph of this line, y equals n plus 1 times x plus 6, in the standard xy coordinate plane passes through the point 4, 8. So whenever they give you a point, a good thing to do is to use xy, right? And then you kind of know what you have to do next is sort of plug those in, right? So we plug in 8 here, and we plug in 4 here, and we distribute the 4n plus 4 plus 6. 4 and 6 is 10, so 4n plus 10. We could subtract the 8, and we get 4n plus 2 is 0. We bring the 2 to the other side, making it -2. We divide by 4. We find n is -1/2. Just make sure that they're asking for n, and they are. A computer repair person charges this per hour. Okay. So we represent that with a fractional unit plus an additional mileage fee. Okay. So this is setting up a linear equation. So it's probably a cost function in terms of sort of. Well, okay. So yeah, if it's a cost function, it usually has this format where it's sort of like 50 plus 2x, you know, where it has a flat rate and then a slope and a number of hours or miles or whatever. So that's what we're expecting to see here then. And whatever has a fractional unit, that's going to have the sort of, you know, x hours next to it. And then flat fee. Call it D, right? The charge per mile varies directly with the square root. Okay. So, yeah, let's just scrap that. So it's not going to be sort of linearly proportional. So the charge for mileage varies directly with the square root of the numbers miles traveled. If 1 hour plus 25 miles traveled costs this, what is the total amount charged for 1 hour plus 36 miles traveled? Okay. So this question is a little bit harder than I originally anticipated, but that's all right. Let's see. So 1 hour, so that's, if it's $50 per hour, that's going to be $50 plus 25 miles traveled. So 25 miles traveled times the number of miles traveled. We'll call that X. If that costs 140. So this would be if it were linear, right? But it's not linear because it tells us that the charge varies directly with the square root of the number of miles traveled. So I need to put a square root symbol on my number of miles. Alright, so now we have the equation. So we could actually solve this for X, but actually we don't need to because we can just replace 36. Okay. Rad X equals question mark. Well, yeah, we actually will have to solve for X because we have two unknowns, the X and this question mark, which would be the output if we had 36 be the number of miles. Okay. So, right, so let's try to solve this thing. So we subtract 50 from both sides. So that's going to give us a 90 over here. Then we divide by 25. Right? So, calculator, 90 over 25 gives us 3.6. And then we square both sides. So 3.6 squared equals 1296. Alright, so that's our value of X. So this gets plugged in here. Well, actually, we can even plug in for the square, because the square root rather. So we could plug in this for radical X. Alright, so we have 3.6 going there times 36. Alright, so let's see, 36 times 3.6 and then add 50, 179. Okay, the right triangle below, YZ is 10 units and XZ is 4 units. What is the sine of Z? So sine is opposite over hypotenuse. We don't know the opposite side, so we have to use Pythagorean Theorem. So let's call it X. So we'll do X squared plus 4 squared equals 10 squared. So X squared plus 16 equals 100. Subtract 16. We get X squared equals, it's at 84. Then square root both sides. So we get X equals rad 84, which can be simplified into, let's see, 4 and 21. So 2 rad 21. So here we could write 2 rad 21 for the opposite side. And then we want sine of the angle. So it's opposite over hypotenuse, which is going to be 2 rad 21 over 10. And then the 2 and 10 might cancel, but actually this is a choice already. Alright, last question. A triangle ABD is reflected across the line y equals x to have this image. What are the coordinates? Okay. So we have to find the transformation rule for when we transform by reflecting in the line y equals x. Okay. So let's take a point which has an x coordinate of 1 and a y coordinate of 10. Right? And we'll see sort of where this point will fall under this transformation. So what we'd expect is we'd expect that the sort of distance is preserved away from this line, and so therefore we kind of expect it to be somewhere here. Although my drawing isn't quite good, it should be a little bit higher. Okay. So actually the position where it will land is having an x value of 10 and a y value of 1. So what started at 1 comma 10 became 10 comma 1. So in other words, the coordinates switch place, right? And you could know that also by knowing that a reflection in the line y equals x is equivalent to a sort of taking the inverse if you have a function, right? And when you take the inverse of a function, the first step is to switch x and y, right? So basically instead of mn, we're going to have n comma m as our choice.